Other factors like thermo, that means temperature, and haline. Haline is actually referring to salt. So salty and cold water sinks. And the salty cold water is sinking in the North Atlantic, and that is driving a current that travels around on the surface of the ocean, and then it sinks in the North Atlantic, and it travels all the way around the world and comes back by the surface currents again. So that thermohaline circulation caused by cold, salty water. It's not just sinking in the North Atlantic, as we'll see in a little bit. There's some sinking around Antarctica here because of the cold conditions there. So let's think about why we get thermohaline circulation. If you look at the surface currents, we have the Gulf Stream, and that Gulf Stream is warm and it's evaporating as it heads north. It's also cooling as it heads north. Well, warm water is less dense than cold water, and salty water is denser than fresh water. So with that evaporation and with that cooling, it's getting saltier and colder. It's getting denser until it gets so dense it sinks. One of the reasons the Atlantic is denser and saltier than the Pacific Ocean is because of the Isthmus of Panama. Think about those trade winds. Remember the trade winds? We've been talking about them quite a bit. We've got trade winds blowing across here. Well, trade winds, as they blow across the ocean water, they're going to cause evaporation. As they evaporate ocean water, they're going to carry that over across the Isthmus of Panama into the Pacific Ocean, leaving behind the salt because the salt doesn't evaporate. So the Atlantic Ocean is saltier than the Pacific, and so that gives us an opportunity for sinking in the North Atlantic because of the extra salty water. If we look at a larger area of the world, we see that the thermohaline circulation starting out in the Atlantic, sinking in the North Atlantic, and then wrapping itself all the way around the world, coming up in the Pacific and also coming up in the Indian Ocean. How do you talk about flow of something as big as an ocean current? Well, you might compare it to something like the Amazon River. 85 Amazon rivers worth of flow here. These are in spurdrups, and one spurdrup is 1 million cubic meters per second. That's a lot of water, but it's got a big ocean to travel over, right? So this is kind of a slow-moving current with a very wide flow that allows it to carry that much water. A huge amount of water, 17 million cubic meters of water in this part of the North Atlantic. Okay, that thing is moving, traveling around the world. Here's some of the places it goes. So it's sinking here, sinking here. There's also sinking water here and over here and here. That's deep water formation, places where the water is sinking. Okay, so let's follow this water that's coming down out of the North Atlantic. Where does the water come back up? So we've got sinking in the North Atlantic and sinking around Antarctica, but we also have equatorial upwelling. Remember that? We also have West Coast upwelling. We have Southern Ocean upwelling. Let's talk about that one, Southern Ocean upwelling. How does that happen? And by the way, the oldest water comes back up in the North Pacific, and we'll talk about that in a moment. Let's do the Southern Ocean upwelling. Do you remember the winds? Down in the Southern Ocean, we have the westerly winds creating the west wind drift. And if we get right down to the pole, there's a little edge of Antarctica there. We've got a little bit of east wind drift here, and we have the polar easterlies. Remember the polar easterlies? Now think about these winds. These are converging winds. When the winds converge, Ekman spiral causes a turn in the ocean currents. And notice what's happening to the ocean currents. They're diverging. Now keep in mind that we're in the southern hemisphere, so compared to both of these winds, the ocean current is going to turn to the left. So if this one turns to the left, it goes that way. If that one turns to the left, goes this way. Okay, notice these ocean currents are diverging. These are the ocean currents, and they're diverging. If you have diverging ocean current, what happens? Upwelling, because you have to have some water coming in to replace the water that was there that diverged away. Okay, so we had sinking in the red circles here, sinking here and here and here. Sinking is the deep water formation in these places. But we also have upwelling and surface water coming up. Now rising. Look at the rising water here. All these yellow circles are places where the water is coming back up. This water comes back up, and you can see this diagram is really nice and complicated. Lots of different paths for the different water in the thermohaline circulation, also known as the global conveyor. So North Pacific, the oldest water comes up here in the North Pacific, and that surface water is heading, and it's coming from the Indian Ocean down Africa and back up along the surface currents now, not deep, but up the surface, all the way up along Africa's coast or through the South Atlantic. And normally we don't get ocean currents crossing across the equator, but right here they do because of the shape of South America. As the current in the southern hemisphere hits South America, now it can't really turn south because it's at the wrong angle, so it just continues across, and that's part of what drives this thermohaline circulation. So it keeps on going farther north again, up into the Gulf of Mexico and into the Gulf Stream and back into the North Atlantic. And remember that in this area it's cooling and getting saltier as evaporation takes place until it's so cold and salty that it sinks in the North Atlantic. And that's thermohaline. Warm North Atlantic current warms Europe. This current coming up here across the North Atlantic, it's not drawn quite right here. It goes more across this way. That's bringing warm water into Northern Europe. If this were to slow down, which we think is happening, then climate change may be slowing down thermohaline circulation and therefore causing cooling of Europe. Only thing is that we're warming Europe even more than we are cooling it from the thermohaline circulation, so I don't think Europe is going to really cool off. But we are seeing a little cool spot in the North Atlantic right there.